diving in, the majority of enterprise data today is not on GenAI applications and assistants. It's still at only 1% of the actual enterprise data is within GenAI. So the majority of GenAI is trained on publicly available data, which gives high-level generic answers. It's not really specified to enterprises, just how not allowing them to be as effective as they could be. And most enterprises say that 60% of their AI products, the vast majority of these projects are not on AI ready data and will fail throughout the next year, 2026. Additionally, the growing unstructured data adds additional complexity. And a lot of the reason why the majority of enterprise data is not within GenAI applications or assistants is because that 90% of it is unstructured. And traditionally, this has really been a gap in the offerings of most data lakehouses or data management solutions. They're great at doing traditional structured or data warehousing, but with unstructured data, that was really an untapped potential. Until now, with watsonx.data Premium Edition in this latest iteration, it really allows enterprises to have more accurate RAG by up to 40% more accurate and up to a 50% reduction in cost of doing these retrieval augmented generation GenAI applications or projects. And this is really possible because watsonx.data is the only hybrid open data lakehouse on the market. It also allows for a multi-agentic workflow, which really allows you to optimize specific workflows for specific engines. And it really focuses on GenAI ready, which I will also share a demo of what that looks like, really allowing you to leverage the value that's in unstructured data, and it does this through being able to better prepare that data, optimize for price performance, and really simplify the data access and deployment. So when we think about how watsonx.data helps organizations go beyond the conventional RAG, which has many shortcomings, not being able to understand unstructured data, it really does this by being able to have superior accuracy through a multi-engine, multimodal data lakehouse architecture. And it's really integrated with now even more integrations and agents. And that allows you to mature not only the data itself and how it's stored, but also the integration and the data intelligence capabilities. So you're able to ingest these structured and unstructured documents at scale from a variety of sources, including FileNet, Box, SharePoint, Google Docs, etc. And then you enrich and govern that data by creating a vectorized embedding and structured derivatives, and then being able to deliver that data across a broad spectrum of workloads. And you can see here now with the DataStax acquisition, that's a great solution, one of the engines you can use specifically for building GenAI applications. Milvus, which I'll cover in the demo shortly, is great for using the GenAI assistants. Spark for AI and ML workloads, Presto, Prestissimo, Spark even with Gluten as well. So there are lots and lots of different options that you can really pick and choose from that will be what's best for your specific workload. But before we move forward, I really want to level set on what the vector database is and why this is really powerful, because I think it's the heart of how to make RAG and unstructured data available for enterprises everywhere. And I wanted to start with this error message because I think we've all seen this before when you're trying to find something and it's saying maybe you didn't spell that correctly, maybe you capitalized something, it shouldn't have been capitalized, or you need to try a different keyword, because search up until recently has been really keyword focused. You have to put in the right keyword, and it's really just looking for the exact match. So if one letter or if one vowel is off, then you're not able to match and find what you're looking for. And the change here with the vector database and vectorizing unstructured data is that now you're looking for meaning, not keywords. And so going beyond the match for match, it's now using semantics. And that really means the meaning of language. So beyond just looking at the exact keyword, we're looking at what's the deeper meaning. So to think about vectorized embeddings and vector databases, think about all of the words from an unstructured document. Say, for example, an interview transcript. Then you feed that into a meaning calculator, if you will. So that calculator, the vector database, then turns an idea or a tone or a topic or a set of words into a set of numbers. And this is like the GPS coordinates, which you can see here. But instead of a physical location, it's showing you a location in the meaning space. So it takes these two chunks of text, for example, that may be about the same thing, even if they don't use those same exact words, keywords, and it can link them or have them be close together in the meaning space. Whereas two chunks of text that are totally different would be further apart. So this lets the system, this vector database, find and group specific ideas instantly, like pulling all the moments across hundreds of interview transcripts where customers talk about hidden fees or trouble logging in, even if they phrase those specific topics differently. So the vector embeddings are really these coordinates. So it's a list of numbers that captures the meaning, the semantics, inside unstructured data, like a sentence from an interview transcript. So Milvus is the free vector database that comes within the watsonx.data solution. And it's a vector database engine that's really purpose built to store those coordinates and search them incredibly fast. So when you ask a natural language question, the model also turns your question into its own set of coordinates. And then it starts to look for those stored vectors that are closest to what your question vector is about. And this really is, again, giving you the most similar semantic meaning instead of just whatever has that exact same keyword. So when we think about Milvus within watsonx.data, this is not just a view on the metadata, it's its own specialized database that's optimized for vector indexes and similarity searches. And that metadata about those embeddings, i.e. the document ID, the chunk ID, the classification tags, the study name, the sensitivity, all of that is stored within watsonx.data's metadata layer. Milvus itself doesn't run inside of Cloud Object Storage. It's a separate engine. However, you can configure it to store index files and raw vector data in a Cloud Object Store, which is a more cost-effective way and is a great back-end storage layer option. So the split here is really Milvus is the high-performing approximation of the nearest kind of neighborhood search for a vector data. And then the metadata layer, which in watsonx.data is with the Iceberg catalogs, gives you that queryable context. It also can provide now lineage, governance, and access controls. So this helps enterprises get faster semantic searches, again, using natural language, understanding the meaning and the compliance reporting that many enterprises need for those workloads. So I want to go into the actual demo now so I can show you what this looks like in real time. So here we are in watsonx.data Premium Edition. Can see that I have, I'm in a sample project. I have lots of assets that are available in jobs, but when we look specifically in the data flows, we can actually create our own unstructured data flow, which is what I want to share with you today. So we'll just click create this. Again, you can see how this is low to no code. So we'll just call this And we're going to be taken to a very easy to use, low, no code environment where we can just drag and drop and create our own specific data flow for unstructured data. And it'll start with getting our data assets. I already have some invoices that are available, so I'm going to click and upload all of these indexes that are available. And then I can move to extract. So I'll just click and drag that, and then I will connect it. So all of the invoices will then go to this next step, which is the extraction, which X.Data can extract raw files, so PDF, docs, text, audio, video, and I also listed out the multiple different sources, including SharePoint and Google Docs and FileNet. And then it converts these raw files into a clean text using OCR, optical character recognition, and speech to text for the audio or video as needed. And the output is normalized, and then it's stored in the data lakehouse with the source pointers. Next, I want to make sure we have some PII and HAP, which is specifically that high assurance, highly sensitive, protected data. So I will look down here for my quality, and I'm going to add this one. So after we extract it, I want it to immediately go through. So this is going to, watsonx has the ability to detect the personally identifiable information as well as the very highly sensitive information to tag and redact that per the specific policy that you set up. And these annotations drive masking and routing and access control so that sensitive content is protected and governed end to end. So now let's do some data class assignments because that's important. So we'll drag and move this over. We'll create a couple rows here. Within the data class assignments, each document gets mapped to a governed data class. So in this interview transcript example, it could be the transcript, the screener, the methodology, the notes. And that class determines default retention, sensitivity levels, and who can access that. Next, we'll look at the terms and classifications, which is a very important one. We'll connect these two so this data is following this pipeline, this flow. So X.Data auto extracts business terms from the top 100 business terms that we are very aware of, and it applies the topic labels. So for example, overdraft fees, mobile friendly, mobile login friction, savings goals, whatever these terms that are showing up in an interview, for example. And it's using also your glossary of terms and taxonomy. And this becomes searchable metadata that you can then filter and roll up insights across a vast amount of interview studies, for example. And you also have the ability to add your own company, department, or project specific terms or parameters within your specific use case and add that into the terms and classification step. Next, you can also see chunking. You want to chunk or break up the data. We'll connect that. So with chunking, you're having these long transcripts. They're split into semantically, meaning coherent chunks. So anywhere from 500 to 2,000 tokens with the boilerplate removed or paragraph or speaker structure preserved. Each chunk can keep a backlink to the original file and the character offsets for auditability, as well as this specific chunk and giving it some sort of identification allows you to then later query these unstructured documents and to be able to go to the exact area that has the highest correlation of similarity based on the meaning of that section of text. And then we will embed. So let's moving down to in the transformation section. So we will connect that. And each chunk is converted to a vector embedding with a large language model embedding model. So that system kind of understands the meaning or the semantics, not just the keywords. it stores the vectors alongside the chunks metadata. So this is everything around the study, the segment, the date, the sensitivity, the tags, etc. And finally, to generate the output, you can leverage watsonx.data Milvus, which I covered earlier, which is available out of the box with x.data. I'm just going to have to connect to my specific Milvus environment, which I will do here. Select that and then connect it all. Now, watsonx.data out of the box can have these flows created, or you can create this once and then use it for everything. I wanted to go through to walk you through what each specific step is doing. You also have the ability to further fine tune that as well. We take a step back. I want to show you an existing data flow that I've already created, so we won't save or run what we just walked through. If we look at this specific data ingestion that I did, you can see that it took us through a series of processes. So the data ingestion step, what is included within the data ingestion, it will actually show me the code of what it's going and ingesting from these invoice documents, data transformation, enrichment, curation, setting up the entity table, and then putting in the entity table enrichment as well. And it walks you through each of these. And then under the advanced setting, it was disabled for this demo, but you also have the ability to select categories that you have the business terms, the data classes, the different kinds of classifications that can be applied to your data. And you can further customize that as you see fit. As we step back, I want to show you specifically how the Milvus vector database, which is really the focus of this demo, what that looks like within the traditional watsonx.data infrastructure manager. So I clicked on that admin console. And when we go to the infrastructure manager, we can see everything that is included in what we have so far. So you can see all of our different storage. We have Iceberg storage on IBM Cloud Object Storage. We have a Spark, we have Hive, etc. We have this Milvus, which is the indexes are being stored within Cloud Object Storage I mentioned before, and then it's connected specifically to this Milvus server, to this Milvus engine rather. And so we're able to understand who are all the groups, who has access to that, etc. So I hope that this brief demo and walking through really specifically what the vector database is, what a vector database engine is, why does it matter, why is it so critical specifically for unstructured data, and helping with our GenAI applications, assistance projects, and really ensuring that we can bring in more enterprise unstructured data and do that in a secure and governed way. Thank you so much, and I will see you in my next video.